Okay. What we have here is a bar woman slides a pint glass of beer along the counter, so that leaves her hand with a speed of 3.5 meters per second. The mass of the full glass is 1 kilogram, and the coefficient of friction between the glass and the counter is 1/4, as 1/7. Find the frictional force. Now, what happens is your glass is just before it leaves. Okay. Well, I actually have a shape for this. So guys, your glass, okay, is going to leave the table at this point here, and it's moving at a certain speed. The speed it's moving at is 3.5 meters per second. Okay. Now, what happens is you have to find out the frictional force, and the frictional force is always given to you by this formula here. The formula is called mu r. Okay. So when you have a weight, when you have weight acting downwards, okay, so your weight is acting downwards, there must be a reaction force acting upwards to cause you to balance. This reaction force is called a reaction force to the ground. Okay, so what goes up equals what goes down. R must equal your weight. Your weight must equal mass times gravity. Therefore, your weight is 1 multiplied by 9.8. Your weight is equal to 9.8 newtons. This means your R value is equal to 9.8 newtons because you're neither ascending nor descending. Okay? So, to find your frictional force then, your frictional force is 1/7 of this R value. What's 1/7 of 9.8? Can you tell me? 1.4? 1.4 newtons. Now, this 1.4 newtons is friction. Friction always acts in the opposite direction to your motion. So your friction force is acting to the left. It causes a deceleration. Okay? So force equal to ma. This frictional force of minus 1.4 n is equal to your mass of your body. What's the mass of the body? Mass of the body is 1 a. So therefore, we can just get rid of the n, by the way. The n is actually the units, okay? A therefore is a deceleration of minus 1.4 ms to the minus 2. The distance to which the glass will travel before coming to rest, you're talking u vast there. So u vast has a u value of 3.5, a v value of 0, an a value of minus 1.4, an s value of what we're looking for. What formula should we use, guys? V squared equals u squared plus 2as. That will mean that v squared is 0. It's 3.5 squared plus 2 times minus 1.4 multiplied by s. Bring that over to your side, you're going to get a 2.8s equals 3.5 squared. Will somebody divide 3.5 squared by 2.8, please? 4.375 meters. You see, a fairly bog standard question, just with a bit of friction involved, right? The key thing to remember there was that your reaction force acting upwards equals your weight. So therefore, the frictional force is equal to mu times your weight. Whatever your mu value is and whatever your weight value is the force going to the left. Any questions? Yep.
What is the mu?
Mu is a Greek letter. It's also known as the coefficient of friction. It tells you how much of your weight is transferred across as frictional force against your motion. Okay? Now, number 5. A sled and its occupants have a total mass of 800 kilograms. The coefficient of friction is, make the sled look like this. There we go. Sled. Now, this sled here says the coefficient of friction mu between the sled and the snowy ground is 1/8. If a husky dog can pull with a horizontal force of 200 newtons, find the limiting friction. The limiting friction is the force required to move the sled. Okay, so what you're going to do is you're going to do F equals mu R. Now remember, R equals your weight. So the weight acting directly downwards is what, guys? 800G. 800G is also known as 800 times 9.8, which will get me 7,840. 7,840 newtons going directly down. Your R value going directly up. R equals 7,840. Your F value therefore is 1/8 of 7,840. So what's 1/8 of 7,840? 980, thank you. 980 newtons. Wait a second. Alright, this is question 5. Yeah, it's 980 newtons. Yeah. Okay. The least number of dogs needed to get the sleigh going across horizontal ground. How many dogs do we need if they work at 200 newtons each? 5 of them. 5 dogs will get me 1,000 newtons, which is just enough to start pulling it along. And how many newtons would you say? Because it's 1,000 newtons in total, and so you have 20 newtons over. So you're going directly to the right at 20 newtons. The acceleration, if in fact the least number of dogs was used. So F equals ma. We're talking about 20 newtons of force being equal to, what is it, 800 kilograms of weight or mass multiplied by A. A equals 20 divided by 800, which is, anybody? 0.025 ms to minus 2. Perfect. Okay, another very simple question. Moving on to question 8. Particle of weight W is pulled with constant velocity over rough horizontal ground. The pulling force has a magnitude of 1/5 of the weight and makes an angle alpha with the ground, where tan alpha equals 5/12. Find the coefficient of friction between the particle and the ground. Interesting. So, if I remember correctly with one like this, is that you draw like a block representing your object, like so. You draw some rough ground, like so. You draw the pulling force, it's going up this way, and so this pulling force has two components. It has a component that's lifting it off the ground, it has a component pulling it to the right. So there's two different ways this can go, up and across. Now tan A is 5/12. Okay. Now we're just going to, while I'm here, I'm just going to break this up into a 5. It's 13, isn't it? 5, 12, 13 triangle. Opposite is opposite of our hypotenuse 5/12. Cos A, anybody? Cos A? 12/13, and finally sin A. Sorry, 5/13. Okay, stop it there. Now, what we have here, guys, is the pulling force has a magnitude. So we're pulling it with 1/5 W. Is everybody happy with that? Going up this direction here. Now, what about this part here then? 1/5 W. Okay. And this is going to be 1/5 W. Anybody? Cos A. 1/5 W. Sin A. And we use our sin A and cos A, and we're going to get a 12/65 W. 12/65 W, and the other one 1/13 W. Now, find the coefficient of the pulling force and makes an angle A to the horizontal, where A is 5/12. Constant velocity. See the word constant velocity? What does that mean? Okay, Net force going right equals 0. Net force is 0, okay? It means it's all perfect balance, okay? Now here's what we're going to do. This is a complex question, okay? The first thing is, what goes up must equal what goes down. What we always know what goes down is the weight. And what's the weight? The weight is just equal to W for this question, isn't it? Okay? Now, what goes up is R. But R usually equals W, doesn't it? But imagine this, okay? Imagine you're, let me see, you're getting pulled up by a rope, but you haven't left the ground yet. You suddenly feel lighter than you are, even though you're still in contact with the ground, right? What happens is your weight is still the same, but your reaction force, that's what your feet feel. So when a rope starts to lift you, you start to feel you feel a lot lighter even though you aren't. That's because your reaction force is being reduced. It's no longer equal to your weight because it's not taking all of your weight. So weight is going down, equals your reaction force going upwards. And what else is going upwards? Your 1/13 of W. W over 13 is also going up. This means that your reaction force is, anybody? Your reaction force equals W minus W over 13, which is 12W over 13. That's your reaction force, okay? Now, when we're talking about the sled going left to right, we're talking about two different forces at play. We're talking about the pulling force going to the right, and the pulling force going to the right, and the frictional force slowing it down to the left. So you have two different forces at play here. Now, we know that the pulling force equals what, guys? Pulling force, this one here. What is it? 12 over 65 W. Our 12 over 65 W is pulling it to the right. What's pulling it to the left is friction, and friction equals mu R. What's our R value? 12W over 13. Mu times 12W over 13 has to equal what? Or 12 mu W over 13 will have to equal 5W, because both forces are in balance. There's no net force because there's no acceleration. No acceleration means no net force. W's will cancel. 12's will cancel. So we're just going to have 1/13 mu equals 1 over 65. Bring the 13 upwards. 13 over 65, anybody? 1 over 5. So that thing is 1 over 5. Is that the answer, is it? Yeah. Does you want me to do anything else with that? Okay. So what one are we on now? Question 10. A particle of mass 10 kilograms is placed on the plane inclined at angle A to the horizontal. Okay? Where tan A equals 3 over 4. The minute I see tan A, you guys are right? Now the minute I see tan A, guys, I always say cos A is 3 over 5, sin A is 4 over 5. A particle is pulled up the plane by means of a string, which makes an angle B with the plane, where tan B is 12 over 5 over 12. So I'm going to go for cos B being the hypotenuse being 13, so opposite 5 over 13. Oh, sorry, 12 over 13, yeah. And sin B being 5 over 13. Okay. The tension in the string is 130 newtons. Find the acceleration of the particle. No, dokes. 10. Okay. So here's what we're going to do. We have a plane, very similar to projectiles, okay? we're going to have our box, which represents our object that we're pulling up the hill. We're then going to pull this box on this hill, like so. And there we are. Okay, there it is. We got up the hill. Now, what I'd like to do first of all is break up its components. Remember, we used to break up gravity into its components going straight down and straight across. So I'd like to do that as well, okay? So what we're going to do is we're going to break it up into a gravity triangle, or in this case a weight triangle, okay? This weight triangle is going to be in red here, so we're going to go perpendicularly down, straight across and down. So that is our weight triangle, okay? Weight has to act directly down towards the Earth's core or surface, okay? So what is the weight of this object? 10 kilograms multiplied by 9.8. Talking about 98 newtons there, aren't we? 98 newtons. Okay, so 98 newtons directly down. What did we used to do regards the projectiles? The angle is A of the plane. So that will be 98. Anybody? This one going down here? Cos A. And the other one? Sin A. Is there any friction in this question? Okay, there's friction in the second question. Okay. Now, the deal is with reaction force. Okay, reaction force only works perpendicular to the surface you're on. Okay, so example being a human being on level ground, your reaction force goes straight up, your weight goes straight down. Everybody happy with that? Now, tilt this full picture like you're walking down the side of a hill. The reaction force is now pointing this way. However, weight due to gravity still goes straight down. Alright? Now, do you ever notice that the W and the R are no longer in balance? And what this will mean is you'll have a net force causing you to slide down the hill or fall down the hill. So you ever notice that walking down a hill, you could accelerate forever, and if you weren't going to fall over something, you could just keep on accelerating for a while. That's why that happens, okay? So bearing that in mind with this slope here, what we're going to say is that your R value is going straight up. Please remember that your R value is directly opposite to what value? The R value here is directly opposite to your 98 cos A. That's the component of weight it's in competition with. Because you notice the way you're not sinking into the wedge and you're not levitating above the wedge. That means that these two forces are they're equal and in harmony with each other, okay? That's if we didn't have any pulling force on us, okay? So next thing we got to consider is, that's great if there's no external forces, but there is an external force. So what is the external force we're looking at here, guys? What's it? A pulling force, isn't it? And the tension in the string is 130 degrees. So look at this, okay? Now, you're 130 degrees. We start pulling this from its center, or just up here. I'll get a new color just to stop confusing. Green here, okay? So we're pulling this with our string. And our string has two components, because it says that we're pulling it up at 130 newtons. So this 130 newtons is going up in this direction here. And we also have this direction here and this direction here to consider. So, the 130 breaks up into what, guys? Can you tell me? It's going to be 130 cos alpha, 130 cos beta, and 130 sin beta. Everybody happy with that? 130 cos beta is 120. 130 sin beta is going to be 50. So it's going to be 120 and 50. Okay? Everybody happy with that? Now, there is two equations of motion going on here at the moment. I'll explain both equations of motion. Now, this is the way I do it. This is called, any of you ever hear of Newton's second law? Anybody tell me? Newton's second law?
An object in motion staying in motion unless followed by an outside force.
I think that's it. Okay, Newton's second law, okay? F equals ma. The force applied equals the mass multiplied by acceleration, okay? Now, we have two directions to consider. Direction one is parallel to the plane, so you'll always see me do arrows like this. If I'm doing perpendicular to the plane, you'll see me do arrows like that. Let's start off parallel to the plane, okay? Now, does it say if it's going up or down? Pulled up. It's going up. So what does that mean about its acceleration? Mass by acceleration. Acceleration is going up the inclined plane. What else is going up the inclined plane? The 120 newtons of force is going up the inclined plane. What's working against it to bring it down the inclined plane? Anybody tell me? The 98 sine alpha. And what is 98 sine alpha? 98 times 4 over 5? Oh, is it?
There's two triangles. You've got that side A and side B.
This one here? Just this 3 over 4, guys. That's the opposite is 3 and the adjacent is 4. So that should be sine A is 3 over 5 and cos A is 4 over 5. Thank you. So it's 98 multiplied by 3 divided by 5. What you get? 58.8. So this 58.8 newtons, which corresponds to this part here, is acting downwards against it. So minus 58.8. Everybody happy with that? What's the mass of your object again? 10, isn't it? And A is going directly right up. So what's your 120 minus 58.8? 120 minus 58.8, anybody?
61 points.
Alright, and then divide 61.2 by 10. 6.12 ms to the minus 2. That is your acceleration. Okay? Shh. Now lads, using what we already know, what we're then going to do is we're now going to, we're now going to modify this equation to incorporate frictional force. Now first of all, so zooming in, where do you think the frictional force should be attached here, lads? Where? It should be going this direction downward, shouldn't it? I'll use again something different here. No colours at this stage. So we're going to attach a frictional force at the end, right? The frictional force opposes motion. Okay? So this frictional force equals mu r. So this last equation I had will now have a mu r attached to the end. The problem is I don't know what the mu r is. Okay? So I'm just going to leave this equation as is at the moment. I'm now going to make a new equation. I'm going to make a new equation here, guys. So it's what goes up equals what goes down perpendicular to the plane. Okay? Now what's going up is this. What's going in this direction is the 50. Do you see the 50 from the string pulling it upwards? That's going upwards. What else is going upwards is your R value. It's going diagonal left up. And is there anything going diagonal right down? The 98 cos A. And 98 cos A is 98 multiplied by 4 over 5, which is 78.4. Okay. Now, everybody understand what goes up equals what goes down. The tension in the string is pulling upwards at 50, perpendicular to the plane. The weight of the object is driving it down at 98 cos A, which we learned now is 78.4. Okay, and that's it. Find the R value. The R value is going to be 28.4. Everybody happy with that? Now, your mu r all of a sudden, ma is 10a. The friction is going to cause a slower acceleration than last time. So it's your 120 going upwards, your 58.8 going diagonally right down, or diagonally left down. And what's mu for this question? A quarter. So it's going to be a quarter of your 28.4. And what would that be in total? Sorry, I didn't hear any of that.
7.1.
Did you divide by 10 already, did you?
No, that was just the last one.
Oh, so that's 7.1. So what's 120 minus 58.8 minus 7.1? 54.1 equals 10a. A will therefore equal 5.14 meters per second. Yeah. Okay, lads. So